Have you ever wondered how scientists separate mixtures into their individual components? Allow me to introduce you to the fascinating world of chromatography, a technique that does exactly that. Chromatography is like a magical sieve that filters out the components of a mixture one by one, helping us to see what's really inside. But this isn't just a high school science experiment. Chromatography is a powerful tool that has far-reaching applications. In the realm of pharmaceuticals, it aids in the creation of life-saving drugs. In environmental testing, it helps us understand and monitor the health of our planet. And in the field of forensics, it's often the key to unlocking the truth and delivering justice. Chromatography is everywhere. It's in the food we eat, the medicine we take, and the air we breathe. It's an unsung hero of science, quietly making a difference in our world. Now that we've set the stage, it's time to delve into the different types of chromatography. Chromatography is not a one-size-fits-all method. There are different types based on what you're trying to achieve. First, let's talk about liquid chromatography, a powerful technique often used in the pharmaceutical industry and environmental testing. In this type, a sample is dissolved in a liquid known as the mobile phase, which is then transported through a column packed with a stationary phase. The different components of the sample interact differently with the stationary phase, causing them to separate at different rates. This allows for identification and quantification of the components. Liquid chromatography excels in separating compounds that are thermally unstable or have high molecular weights. Moving on, let's delve into gas chromatography. This type is a hot favorite in forensic science and environmental pollution studies. In gas chromatography, the sample is vaporized and carried by an inert gas, which acts as the mobile phase, through a column with a stationary phase. The varying interactions of the sample's components with the stationary phase cause them to separate. The advantage of gas chromatography lies in its ability to analyze volatile substances and provide high-resolution separations. Now, you might be wondering, what's the difference between liquid and gas chromatography? Well, the key difference lies in the state of the mobile phase. Liquid chromatography uses a liquid mobile phase, while gas chromatography uses a gas. This simple difference significantly affects the types of samples they can analyze. For instance, gas chromatography is not suitable for large or thermally unstable compounds, which liquid chromatography handles very well. But that's not all. The choice between liquid and gas chromatography also depends on the specific needs of the analysis, such as sensitivity, resolution, and speed. In some cases, one method may be superior, while in others, the opposite may be true. Next, we'll move on to some other types of chromatography that might surprise you. Continuing from where we left off, let's uncover more types of chromatography. Next up, we have paper chromatography. This technique is quite straightforward and, as you might guess, involves a piece of paper. More specifically, it uses a strip of absorbent paper, such as filter paper, as the stationary phase. The mobile phase, a liquid solvent, travels up the paper by capillary action. As it moves, it carries along the mixture of substances to be separated. Different substances will travel at different rates depending on their solubility in the solvent, allowing for their separation on the paper strip. This technique is particularly useful in the food industry to test for artificial colors or additives. It's also used in forensic science to analyze inks and dyes. Now let's move to thin layer chromatography, often abbreviated as TLC. This technique is similar to paper chromatography, yet it uses a thin layer of adsorbent material, like silica gel or alumina, on a flat, inert substrate. The principles of separation are the same, with the solvent carrying the sample up the plate, but TLC often provides better resolution or separation of components. TLC finds its applications in many areas, including pharmaceuticals for drug testing, in environmental monitoring to identify pollutants, and even in cosmetics to check the purity of ingredients. So, how do these two types compare to the first two we discussed? Well, both paper and thin layer chromatography are simple and cost-effective, making them ideal for quick, rough separations. They also allow for visual analysis, as the separated components can often be seen directly on the chromatography medium. On the other hand, they may not provide the precision and sensitivity that can be achieved with techniques like gas or liquid chromatography, which are more suitable for complex mixtures or when more detailed analysis is required. So, 4 types of chromatography down. But wait, there's more. Last but not least, we have a type of chromatography that's a little different. Let's dive into the intriguing world of column chromatography. This technique uses a column filled with a stationary phase onto which the sample is loaded. The mobile phase, or eluent, is then passed through the column, carrying the components of the mixture with it. The different components separate based on their relative affinities for the stationary phase and the mobile phase. Now, why would we use column chromatography? Well, it's particularly useful when dealing with large sample volumes. It's widely used in the purification of proteins, which are vital for various biological processes, and in the pharmaceutical industry for drug development. Column chromatography, like our other types, allows us to separate the wheat from the chaff, or in this case, the desired proteins from the rest of the sample. So let's take a step back and look at the bigger picture. We've explored the world of chromatography, from paper and thin layer chromatography, great for quick and simple separations, to gas chromatography, ideal for volatile compounds. We've also delved into high-performance liquid chromatography, perfect for separating components of a solution, and finally, column chromatography, the go-to for large volume samples. Each of these techniques has its own unique characteristics and applications. Some might be better suited for certain situations than others, but they all have one common goal: to separate the components of a mixture. Whether it's to identify an unknown compound, purify a substance, or even solve a crime, chromatography is a powerful tool in the hands of scientists and researchers. And there you have it, a quick tour of the world of chromatography. Remember, each type has its own unique applications and characteristics, but all serve the same purpose: to separate the components of a mixture.